Welcome to Sravz Technical Series. In today's session, we will discuss the Makefile we have built in the first session of CPP sessions, Docker Dev Environment Setup, and we will convert the Makefile we have built into a CMake build system. CMake provides us many advantages. It's modern, and if we are building microservices based C++ code base, then CMake definitely helps us in breaking down the monolithic application into smaller libraries and then create the final executable. It also helps us in easy integration testing and unit testing. So in today's session, I'll show testing using GTest Framework, and then I'll also use Visual Studio Code as always, and then we will show how we can do the CMake extension based build and the Google Marks based testing. So I'll switch to the Visual Studio Code. If you recall from the first session, Docker Dev Environment Setup, I discussed that we will use Makefile. So this is the Makefile, which builds our Boost-based REST-based API server. And then we discussed the REST API server here, which is a complex system. We have all these. Then we have REST API router service controller like this, for example. So we have the router, we have controllers, then we have services. So these are all individual microservices which we can build separately as libraries, and then build the final executable file. So if we do that through CMake, it is much easier. So that's why after some user input, I have converted the this Makefile into the CMake build system. So before we go into the CMake build system, I'll just explain the make command we used. So this is the Sravz make target, which depends on these files. And then we call the G++, and then we use standard 17, and then we don't want to print the deprecation warning, so we did that. Then this is boost logs dynamic link macro. We define that macro. If we define this macro, then boost beast will logging library will be attached at the runtime as a shared object. So it won't be statically linked to our executable. And then we have bunch of includes here. These are all our includes. Then for loader, we provided the path where all our shared objects are, ls this directory. We have a bunch of libraries there, for example boost, and then we have redis, etc. And also we have AWS there, then CMake, AWS again. So all our third-party libraries are in that location. All the shared objects which can be dynamically linked. And also, if you remember the Docker build I showed in first session, all our libraries are installed in this directory. Yeah, the local user local lib. That's where we have installed all our libraries in our Docker file. So that's why we provide that path to the build command. So I'll go back to the Makefile. So we provided the user local lib to the loader path. Then this is our output of executable path, backend-cpp. And then we provided bunch of source files. We have the source files, web sources, services, router, controller. All the C++ files are there. And then we provide all the directives, all the libraries that have to be linked to the executable. So these are all linked statically to our executable. So that is our main build command. It's very complex. So what we did is we broken down that complex command using CMake build system. You don't have to know CMake to convert this. So today, after I explained CMake the way I converted this, you might get up to 40 to 50% up to speed with CMake. So I'll switch to CMake. Before that, I'll show the CMake files I have in my source code. So find minus name CMake list. We have these CMakes, right? We have a CMake lists file here. Then we have CMake list file in the tests. Then in the source parent-child hierarchy. So you have a parent CMake, and then in each subdirectory you'll have a CMake lists file. So it's parent. Then these are all in subdirectories are children. And then in the each children you build a particular target. So for example, in this case, this is my parent. In source, this one will build my executable because this is where all my other libraries are. In this the CMake will build a library object. Similarly, this will be an archive file. An archive file is a bunch of object files in it. So this is an archive. So we'll create an archive file here. We create an archive file here. Similarly here, when after these archive files are built, we statically bind these archive files to the executable here. So each directory in itself is an archive file, and then you can write the unit test for just that archive file because it's a library. In the unit test, you can point to just that file, and you can test the functions only in, say for example, controller, services, etc. So that way CMake makes it easy for you to build microservices and unit test them. I'll open the first CMake file. So this is the first CMake file. I won't explain the every line here, so I'll only explain the high level concepts. We have to set the minimum CMake policy, then we ignored that. Then this is our project, we call it Sravz, then language is C++. Then we set certain global level variables, say CXX C++ standard is 17, etc. Then we have included some sub functions. If for example, I'll go to CMake functions.cmake. So there are some sub functions here. I'll explain this when we use it. So I'll include those sub functions here. So it's just like an include file of another list of functions. Then we set some constants here, right? And this one, add definition, we define that macro which is needed for boost. We discussed in the main make command. So we define that preprocessor definition here, which is parallel to this one, right? This minus d boost I defined in the parent CMake. Then we execute process. We set ld config to that location where all our libraries are, so that loader can find them. The loader will run at this point, right? We have the loader. When we run the executable, the loader will get all the shared objects, and then it will load them into the address space. So that is the purpose of loader. So we ld config is used by the loader, then we set that, and we had exception handling here, if loader not found, etc. Gcover is for coverage, code coverage. We'll discuss that at a later point, but we have enabled that here. Then we have to enable testing, so that once we enable testing, C tests are enabled, then the testing framework will pick up the test. So we'll cover testing also in a separate video. Then we add the subdirectories where all other CMake files are. For example, I added a subdirectory here, right? Then I have a source in where I have the CMake file. I have CMake file in source, so I added that subdirectory. Similarly, where all I have CMake file, I add them as subdirectory. So with that, we have covered the parent CMake file. Now we'll go to the individual CMake file. So I'll go to the source CMake file list. Now source CMake file list will build the backend-cpp executable. So the target for this one, so the target is set to backend-cpp. Backend-cpp would be the executable that is built. I'll just ls it, I won't run it. Backend-cpp. It's an executable. So this CMake file list is responsible in building that executable. We have include files like other make files. We have bunch of global variables. Then we create an include directories listing, and we include all our include files. And then for the source files, we use glob to get glob, save everything to source files with extension star.cpp. So everything under source with extension star.cpp will be picked into the source file. Similarly, web sources, services, router, controller source. So we add them all to the sources directory, to the sources variable. And now we add executable, will create an executable called backend-cpp, which takes the target name as backend-cpp, which we defined above here. And the source files are defined here. So with that, we have covered the include files, the source files. Now the libraries that are needed, -l, if you recall that, -l, docker file make, these -ls. We have to provide these libraries that have to be linked statically to the executable. So we go back to the CMake list. So we find packages. Find packages, again a CMake module which can find packages. For example, here we want all boost packages with the required components of these, which we have added in the main. So when we do find packages, it will set up global variables of this one and this one. This one, boost libraries, will have all the libraries linked to it. Include files will have all the boost libraries header files. So we target link libraries. Boost libraries are added here from this find packages, target link libraries. Now target link libraries is what to the back in CPP, target link libraries, we have added boost libraries and all these libraries. We could have added remove -l and add whatever is in the Makefile there, or we can just do it this way. We find packages via this module and then add boost library. Then add libraries, link directories. Wherever the libraries are present, we add this. And then for this executable, we need two config files. So this command will copy these config files which are present here to the build bin directory whenever we build the application. So that's the purpose of the CMake list in the source file. So I'll go through one more C file which builds the archive files. For example, say services, this CMake file. So this CMake file creates a library, an archive file named lib.a. It creates a lib.a. So called services. So it takes all the CPP files here in services and the same process again. It creates an include directories, and then we also will cover the code coverage part in a separate video. In this case, we also want to do some code coverage, so we add this extra flag, but we'll discuss that in a later session. So that's how we create a library. Now the power of CMake is from this extension we get from in the Visual Studio Code. Now to build it, you could either do CMake from the command line, CMake the CLI you could read it online, or you could use the extension. So for example, I'll use the extension now. The CMake extension will show all the CMake files that are present in the system. So if you do the project outline, it shows all the CMake files located in the source code. So my SRC has a CMake file, integration test as one, unit test. So it is showing all those CMake files. Now to build my backend.cpp, I can just go to here and say build it, and it will. So this is the command that is run: CMake build workspace CPP. This is where the build target is. It will build into that. Config is debug config. Now target is backend-cpp. So it picks that target from our CMake. This as that target -j and 8, and these are some parameters it gives. The build is already complete. I already built it, so it's in the cache. So that's why it is using what was built in the cache. So that's how it builds it. And then we can also use the unit test using the unit testing framework. So for example, I have some unit tests here. I'll just run one. So the goal is to add more unit tests using GTests and also using mocking. So we'll do those in a separate session. Using CMake, we get this advantage. We can build it using the extension. So we can create this unit tests and run them through the test runner. In a separate session, we'll discuss the testing, both unit testing and the integration test. So with that, I'll close today's session. If you have any questions or comments, please reach me out in the YouTube channel or in the discussion tab here. Thank you for